Thank you, Christian, for this interesting speech. You showed us that you don't know so much about fish only, but also other kind of species and the relation with hydromorphology. We now continue with Massimo Rinaldi. But first I have to tell you and to assure you that all the presentations will be distributed later on, so they're all recorded, so later on you can read it or hear it in a way. Massimo, also very much involved in the reform project, our Italian friend. You studied geology, but also geomorphology engineering, and working on the University of Florence, and you are going to tell us about hydromorphological assessment. Yes? The floor is yours.
Thank you. Okay.
You know how it works? Forward, backwards, and that's the pointer.
Okay.
Yeah?
Thank you. Okay, good morning everybody. Thank you for the introduction. So I'm going to talk about hydromorphological assessment in a broad sense. The hydromorphological assessment, of course, is fundamental for many scopes. First of all, to classify the status of rivers as required by the Water Framework Directive, but then to identify, to decide what kind of actions we could take to restore a river, and then to monitor, to check, to evaluate if the restoration worked or not, but also other kinds of interventions, for example, interventions related to the flood protection and so on. We need to evaluate their effects on hydromorphology. So I use assessment in a broad sense in this presentation, and I like to start with a very short some definition, basic definition of different words, and just to clarify the sense that I'm using these words. For example, delineation is part of an assessment, but is more related to a delimitation of, for example, boundaries of spatial units that we heard in the presentation of Angela Gornell. Characterization is more a description, a more accurate description of elements of spatial units and factors, and so on. Assessment is really an evaluation of the condition of the river. So we need to express some kind of judgment on if the river works, functions appropriately or not. And monitoring is used in the sense of a periodic measurement or also evaluation of a series of variables, parameters, indicators. So it implicitly includes a concept of temporal repetition of an assessment. So this was one of the first deliverables provided by the reform project. It is the name is Review on Eco-Hydromorphological Methods. So I start my presentation with a very short summary of the results. Of course, you can find this is of a public domain, so you can download this document from the reform web page or the wiki. So basically, we started with trying to define different categories of assessment, of hydromorphological assessment, because we noted that there are many different methods, but they really have some difference in the sense of what they are really assessing. So we divided in the methods in 5 groups. The first 2 are very much related to each other, so we can consider them as 2 subgroups of a same group. These are the physical habitat assessment or riparian habitat assessment. So there are methods to identify, survey, and assess physical habitats or habitats specific on the riparian zones. Then we found that there is an increasing development of what we call it the morphological assessment methods, which are methods which perform a more general evaluation of morphological conditions based more on geomorphic concepts, and they really try also to give a link between pressure and response. Then we have the hydrological regime alteration assessment, which are more concentrated on the alteration of the hydrological regime. And then we have a last group that is a little bit on the boundary, really, between hydromorphology and ecology, because it's the assessment of longitudinal fish continuity. But we noted that many times hydromorphology is often considered associated just with this kind of assessment of fish continuity. So what we have done is a very extensive review of methods around Europe, but also in other states, particularly in the United States, Australia, and so on. And so we reviewed a total of 139 methods, and we divided in the 5 categories these methods, and we made a very extensive analysis. I repeat that you can find the results on the deliverable, so I will not spend much time. But just to give you an idea, here I want to summarize very shortly the strengths and the limitations that we identified for each category of methods. So, for example, the first 2 groups, physical and riparian habitat methods, which are very common, very frequently used for the Water Framework Directive, and they provide really an accurate inventory of habitats. So they are useful to characterize the habitats, but at the same time we noted some limitation, like for example they are very detailed site-specific data collection, so a large application of these methods is often difficult, and particularly we noted a limited consideration on processes. Another limitation is that in some way they consider they define high status or also reference conditions based on the presence and abundance of geomorphic features. That is not always correct, because they fail to recognize that many streams have a structure, a geomorphic structure, very simple, and so this is another limitation. Then, as I said, there is an increasing number of methods that we classify as morphological assessment methods. For example, the MIMAS in Scotland, the MQI in Italy, and the CIRA in France, and so on. I will go more in detail on the MQI later in this presentation. But just to remark, the main strengths are, for example, consideration of physical processes, understanding cause-effect relationships. As you see in this picture, the emphasis of some of these methods is not much on the geomorphic units into the channel, but is also on trying to understand the geomorphic conditions, for example, if there is or not some incision or some change into the geomorphic overall pattern of the river, and so on. But of course, there are other limitations. For example, physical processes are difficult to assess. So here we don't make some measurement of physical processes, but we just include considerations of physical processes into the analysis. And of course, there is a more limited attention to the geomorphic units, which are the strength of the previous category. Then the hydrological regime alteration assessment. There are a number of methods, particularly from Spain and Italy, because probably because in these countries the alteration of hydrological regime is very heavy in some cases. So they are based essentially on quantitative data. They use robust indicators. But at the same time, of course, the limitation is that they require large data sets, long time series, and there is still some aspect that is not considered, such as hydropeaking and groundwater alteration. So to conclude this part, the fish continuity assessment, we also have a number of methods which are used. The strength is that they provide a useful basic inventory of basically of existing barriers, and it's relatively simple to obtain. That they provide some direct link with ecology, but limitation. There are few cases of more detailed assessments and standardized protocols or structured methods. So to summarize this kind of analysis, we made. This is a graph showing the methods implemented, formally implemented for the Water Framework Directive in Europe. And as I said before, there is a bias towards the physical habitat assessment methods. So most countries use physical habitat assessment methods to assess hydromorphology, which are useful, but they are not completely useful for the needs of the water framework and for the restoration to define restoration actions. So the main limitation is that consideration of physical processes remains the main gap, and also integrated use of different components is limited, but is recently increasing. So this, of course, introduced us the one of the main issues of this presentation. That is the importance of consideration of geomorphic processes. The previous presentation of Angela already gave us a broad overview of this importance. But this is just to show you a classical example of a river restoration project in California. This is the project 2 months after the construction. They built a very nice meandering river, because meandering rivers, for a series of reasons, including cultural reasons, are preferred to other morphologies. But just 3 months after construction, the channel failed after a flood, but it was a medium intensity flood. It was not an exceptional flood. So the main reasons were that, for example, the designers did not take into account the historical aggradation and the braided morphology of this river in California, and tried to impose a channel form inconsistent with the runoff regime and sediment supply. So this is a typical example of what in the US call a form-based approach, a cookbook-based approach that is not based on consideration of processes. So I spent just 2 words, because I think Angela already made a good presentation of this structure. In geomorphic analysis of river systems, different landscape landforms are considered at different spatial scales. This already occurs since the last 30 years about in the scientific literature, but there is no a real application into practice. So what we are trying to do is really to develop and to use a hierarchical framework into the reform project, where we have a series of spatial units, and we have different controlling factors at different spatial scales, at different locations, and at different time frames, and so we need to consider in the same time we start from a top-down approach where we try to reconstruct the general picture of the catchment and identify the controlling factors, and then at the same time we start with a bottom-up approach where we build upon the geomorphic units that we identify also in the field, and we try to understand the assemblage of these geomorphic units that characterize a given morphology at rich scale. And we also need to understand the temporal dimension of this morphology. So if in the past these geomorphic units were already there, and if in the future they could be there with some type of restoration action. So this is just an example of application. We have many examples carried out in the reform project. This is a catchment with landscape units, segments, and then segments and reaches. But what I want to emphasize that this is an open-ended approach to allow for optimum use of locally available data sets. So it's not a rigid prescriptive approach. We don't like approaches based on tick points or checklists or cookbook approaches, but we try to introduce such kind of open-ended approach. So another very important component of the assessment, of the hydromorphological assessment, is the temporal context, as I already mentioned. This is a very simple sketch of the concept of a trajectory. For example, the concept of reference conditions in hydromorphology is very problematic. So it's very different from the reference conditions used for ecological indicators, because we need to realize that the river morphology moves through time in relation to a series of driving or controlling variables. So we are, in present conditions, we are just in one point of a very long trajectory. So how do we define reference conditions? So this is because we say that we should avoid a reference condition intended as a precise static morphology. So we should not say that we are now in we have now a meandering shape, but we should have a braided morphology. But we need to understand the past evolution and need to understand why the river is meandering now, why it comes from, and where it comes from, and what kind of evolution could be in the future. So this is essential to identify the actions, restoration actions eventually, maximizing the morphological benefits related to the morphological trajectory. So this is really a key concept. So based on these broad concepts that I tried to summarize shortly, we are developing the overall reform assessment framework, which include both these components, the spatial and the temporal context. So the concept of trajectory is expressed by this graph on the right side. So the spatial context is the definition of the delineation of spatial units in the present conditions. So we start to characterize the river in its present conditions, but then we start to investigate which were the conditions before in past temporal changes, and then we assess the present hydromorphological conditions in the sense of the definition that I gave in the first slide. So we needed to make some kind of evaluation of the morphological conditions of the river. And then we start to monitor the river, eventually to predict possible future changes. So this is the overall structure. And the assessment of this overall framework, as Angela already said, we have a definition of a set of indicators to assess current river conditions and degree of alteration, potential risk conditions in the context of its segment and landscape unit setting. And this information feeds into series of applications. For example, we can identify best condition reaches to be protected, or select most effective locations for restoration and select appropriate actions for restoration. But of course we also need some kind of more practical tool, because this kind of assessment requires much training and much experience, and here the approach of physical scientists is fundamental. I mean, the rule of geomorphology is very, very much crucial in this kind of assessment. So we also need some more simple tool to do this. Just an example of such a kind of tools is the morphological quality index that we developed in Italy. As I say, is just an example. It's not necessarily the method that we say that it should be used. But the main characteristics of this method are that this is very consistent with the reform assessment framework. In fact, the spatial scale is based on the hierarchical approach. There is an emphasis on processes, there is a temporal component explicitly accounted, and it is based on GIS remote sensing and field survey. That is, again, an innovation compared to the physical habitat assessment methods, which are only based on field survey, and in that case it is crucial to identify representative reaches, representative sites in the field, because we recognize that there is a large diversity of morphological conditions in the river, so it's not easy to identify representative sites. So we are developing an extended version, European version. This is in progress within the reform project, will be delivered during the fourth year of the project. Just to give you an idea, this method is based on three sets of indicators. One group is what we call functionality. So it looks at if the basic geomorphic processes functions as we expect or not. Another is the artificial elements and pressures. So there are just artificial interventions, and the last group is channel adjustment. So the temporal component is accounted by some of these indicators. So just to give you some practical example of indicators, these are indicators of functionality. This is one of the indicators of functionality. For a question of simplicity, we defined some broad classes, class A, class B, and class C, with increasing alteration from class A to class C. So we look at the reach scale, if there are or not, for example, with this indicator is the longitudinal continuity in sediment and wood flux. We look if there are or not causes of interruption or alteration of this continuity into the reach. This is an example, the indicator is A6 bank protections, so it's an example of the group of indicators of artificial elements. That is basically a simpler way to evaluate similar things, but we don't need here much interpretation. We just need to calculate how long are, for example, in this case, the protected banks along a given reach. And then just an example of the last set of indicators of channel adjustments. This is the indicator is adjustment in channel pattern. And here we use some historical photos of about 60 or 20 or 50 or 60 years ago, just to make this evaluation. But this does not mean absolutely that we consider this as a reference condition. This just means that we consider a comparison condition in order to assess if there was some big change or not in channel pattern related to some human causes. For example, here we see in the last example, class C, we have a transformation from a braided to a meandering river. So we consider this as an evidence of some alteration into the reach or into the catchment. So we end up with a score, a final score of the index, and so also classes which are functional to the Water Framework Directive. So this index is suitable to classify if a reach is in very good or good status or less. Just to provide you a more practical example, this is the river in central northern Italy, Panaro River. And this is an example where we have limited artificial elements, particularly along the banks. We have here the picture of some decades ago and now, so we see a big transformation. But this is not due to bank protections. It's just due to channel adjustments. So this is again explained why we need to consider processes, why we need to consider not only artificial elements but also natural elements and channel adjustments. And so there was a huge transformation of the pattern and also a big incision of 6 or 8 meters. And also outcropping of clay. The gravel into the river was completely removed, and so we have a river with a clay substrate that is completely different. So we need to consider all these factors. This is just a way to represent the results. The codes here are the indicators, the set of functionality indicators, the set of artificiality, and the set of channel adjustments. So the green line is what we can define our reference conditions, which are really theoretical reference conditions. So they mean no or negligible presence of alteration. And the red lines are the current conditions. So this kind of graph provide a useful example on how to consider which aspects we could consider to improve the river to obtain an improvement in the hydromorphological conditions. For example, in this case, we see that there is a big alteration of this part of the graph. So in some way this facilitates to identify the proper restoration actions that we should carry out. This is another type of representation where we grouped the indicators in the main aspects which are considered by the Water Framework Directive. So this immediately visualizes the main gaps and where we should try to improve the morphological characteristics. 1 minute? Okay. Just a very short look at the future. So I said future trends we need to monitor and to model eventually. So we need monitoring in the sense of periodic measurements of morphological indicators and possibly prediction if we want to undertake some kind of action. So we need to try to understand what will be the trajectory for a given action or in continuing the present conditions. So we have also developed a specific version of the previous index for monitoring that is a little bit more with a higher resolution because we use some kind of function of the indicators instead of distinct classes, and this is more suitable for a series of applications, including evaluation of impacts, monitoring effects of intervention, including restoration projects. Just to show you an example, I'm sorry I arrived here in delay, but just a short example of a case of a restoration project in Italy where the main causes were, as typical in many rivers in Italy, gravel mining, decreasing of sediment transport, and the effects were a strong incision of 3 to 5 meters, loss of geomorphic units, and particularly discontinuity of the lateral interruption of lateral continuity with the alluvial plain. So there was a restoration project including some removal of structures, some channel widening, and some reintroduction of gravel. So just to show you, in this example, we could apply this kind of index, and we estimated improvement. The important part of this evaluation is the difference from before to after the intervention. So we have a number, but the meaning of this number, the main meaning is that this improved. In other kind of interventions, you can estimate a deterioration of the morphological qualities, and I remind you the Water Framework Directive says that we should not deteriorate the conditions of rivers, so this is useful for this kind of application. Just the last slide is to mention that in the monitoring activity we don't need necessarily to apply indexes, but we can also sorry. What's okay? This means that the time was definitely finished. So, but what I was saying is just we need, in some cases, to monitor single parameters and to follow the trend of these single parameters through time. Okay, thank you.